Ladies and gentlemen, tech enthusiasts and cable aficionados, welcome back to another exciting episode of Get Your Tech On. I'm your host, founder of the Volpe firm and chief product officer at OpenVault, and today we have an exceptional treat for you. In episode 93, titled Managing DOCSIS 3.1 and Channel Bonding, Ensuring Optimal Performance, we're diving deep into the world of DOCSIS technology. And joining us once again is the brilliant John Downey, CMTS Technical Leader at Cisco Systems. Together, we'll explore best practices for harnessing the true potential of DOCSIS 3.1 channel bonding to ensure peak performance in your HFC networks. From overcoming challenges with modems that are not bonding to your OFDM and OFDMA channels, to offloading traffic from SC-QAM channels, we'll unveil ingenious solutions to supercharge your network efficiency. And that's not all. We'll also unveil secrets of proactive network maintenance and delve into the pivotal role of profile management application, or PMA, which will help optimize bandwidth allocation around RF impairments. So fasten your seatbelts and get ready to discover the integrative power of PNM and PMA in a quest to provide unparalleled customer experience. Without further ado, let's jump into episode 93 of Get Your Tech On. But don't forget to hit the like button, subscribe, and hit the notification bell so you never miss an episode of our Tech Insights. Welcome back, John, and let's get your tech on.
Nice. And now for the rest of the story. Who was that guy who did that? The PBS or whatever those. What was that guy's name on the radio? And now for the rest of the story.
No, for the rest of the story. I don't remember, but I remember the
Cronkite.
No, that was Walter Cronkite was Mia's favorite news person, our producer over here on the corner. Thank you, Mia, for producing the show. So, but yeah, there's so many good people in our past. Now for the rest of the story.
Yeah.
For today's story, 3.1 modems. And I thought, John, we'd start off talking. So, we spend so much time deploying OFDM, OFDMA, DOCSIS 3.1. We upgrade our subscribers with DOCSIS 3.1 modems. And we expect that those 3.1 modems are just going to start using OFDM and OFDMA so we can give subscribers that additional capacity. But that's not always the case.
It's a hard sell at first also because the saturation of 3.1 devices dictates if you're going to allocate spectrum for it. Because the only one that can use that spectrum is a 3.1 modem. So if you only have a handful, you're like, I can't allocate 192 megahertz. That's the equivalent of 32 single carrier QAMs in my spectrum. Where am I going to get that spectrum?
It's a big chunk of space to allocate.
Yeah.
And we're struggling with getting 3.1 modems still today because of chip shortages. So we're kind of stingy with who gets those 3.1 modems because we just can't roll them out quick enough.
Anyone that's gone to 1.2 gigahertz in the downstream has found spectrum. The 3.1 modem, the 3.0 modem stop at last single carrier QAM is 999 megahertz. But the 3.1 spec goes to 1.2. So we can get another block of OFDM out there if we really wanted to, but not all the plants out there go to 1.2 gigahertz. Some of them probably go to 860 still. Heck, some go to 750. Some really old systems.
Yeah, there's still a plant out there that doesn't even go to 750. They're still upgrading. Yeah. So it's kind of all over the place on what the frequency allocation is of cable operators that are out there, what their upgrade plans are, etc. So to your point, it's a challenge.
And that's interesting also. It reminds me of a lot of systems might have started with 3.1 or 3.0 single carrier QAM and DOCSIS, just DOCSIS in general, down at the low end. But when the 3.1 spec came out, there was a statement that 258 megahertz and above was a must. Below that was a may. It was never a must. So what I found in my own testing was a 3.1 modem would not scan for a primary channel below 258. So I told people, I'm like, make sure if you're going to use, cross bonding of single carrier QAM and OFDM, maybe 32 single carrier QAM with one OFDM block, make sure your primary channels are above 258. I found that the scanning table in the modems would scan above 258, find the primary, and it could still bond with a channel below 258 but it would never find a primary below 258.
So that's probably the first key thing that we want to make sure cable operators understand, having their single carrier QAM. I did that in the last episode with Ron. Single carrier QAM and your OFDM need to be reasonably close together. I mean, not necessarily side by side, but they can't be so low. And I've seen cable operators that will put their single carrier QAMs down even as close in the FM band, just because if they don't have bandwidth, that's where they're going to put them, and then they'll put their OFDM channel really high. And then they're like, well, why are my modems bonding to my OFDM channels? So to your point, make sure that you're getting your SC-QAMs high enough in frequency and close to your OFDM. And then the other thing we'll see happen is they'll say, well, I have frequency at the lower end of the frequency spectrum, right? I have bandwidth at the lower end of the frequency spectrum, and that's where they'll put their OFDM block while their SC-QAMs are really high in frequency. And then they'll have bonding issues.
Yeah. A lot of times, a good best practice is keep your spectrum like contiguous if you can.
It's the ideal.
All the channels close together. I used to say with DOCSIS 2.0, we had load balancing for downstream. If you had a chunk of downstreams on the low end and a chunk of downstreams on the high end, and the modem had a load balance between two different frequencies, in a real cable plant, it's probably negative tilted at the last tap. So you could have plus 5 dBmV at a lower frequency and minus 10 at a higher frequency. So then the CMTS like, hey, let's load balance, and now all of a sudden it doesn't work because at that house the level is so much different.
Yeah, so you're talking about load balancing. What are you suggesting is happening when the CMTS is the CMTS load balancing the cable modem between the SC-QAM and the OFDM channels?
For DOCSIS 2.0, DOCSIS 2.0 is only a single channel modem, right? So it can only lock on to one downstream, and they all have to be primary single carrier QAM. So it could hop around to any of them to load balance. The ultimate load balancing is bonding. You're balancing the load. You're not moving modems at all, right? You're saying balance its load across as many downstreams as possible. 3.1 takes it a step further by saying that one OFDM is just one big channel, but it's made up of 8,000 subcarriers or 4,000 subcarriers, but it's one big channel. So your load is spread across a bigger chunk, right? The bigger the aggregate is, the more you can oversubscribe, the more speed you have individually, but the more speed you have for people to share.
You're just making a bigger highway. You're adding more lanes to that highway when you add that OFDM channel for the DOCSIS 3.1 modem.
Correct.
Now, how about when data is sent to the DOCSIS 3.1 modem, or let's talk about the downstream first of all, and why we're doing this channel bonding. Is that data sent to the DOCSIS 3.1 modem when it's bonded to the OFDM channel? Is it sent both on the SC-QAM and the OFDM channel, or is it sent just on the OFDM channel or just on the SC-QAM channels when the modem is both locked to SC-QAM and OFDM?
Let's back up a little bit because I have this other question come up a lot is, should I make the OFDM primary? And we're finding that it might not be advantageous to make the OFDM primary. Even though it might be more robust for the PLC, the physical link channel.
Mm-hmm.
Or is that what it stands for, physical link channel?
Yes.
I think so.
I think.
But it's very robust. Like 16 QAM. It's so robust, it'll lock on. But we found that if I use a single carrier QAM as a primary, sometimes the modem will perform resiliency better, partial mode better. And if I have voice traffic, I can send that voice traffic over the single carrier QAM and not spread it. Now think about voice traffic. It might be 110 kilobits per second. So spreading it across multiple downstreams or even OFDM, you're spreading a small flow across all this spectrum, creating potentially latency or jitter.
Right.
So by keeping a primary downstream as a single carrier QAM and letting 3.1 modems use that primary, I can also direct its own voice traffic to that primary, a single carrier, 6 megahertz wide DOCSIS Annex B DOCSIS channel, right?
SC-QAM channel.
Annex A would be 8 megahertz. So let's talk about, so I said maybe it might be good to keep a single carrier QAM as primary and not the OFDM. Keep in mind when a 3.1 modem comes up, it'll try to range on an OFDMA upstream.
If it's primary, if the OFDM, if it's
on upstream,
okay.
There is no such thing as a primary.
That's correct.
They're all primary capable, but a 3.1 modem will try to range on OFDMA before it tracks single carrier QAM upstream.
Right.
There's commands in CMTS now to override that, to say, I want all my modems to try upstream 0 first or upstream 1. So you could dictate which upstream you want the modem to range on first,
Mm-hmm.
like register first. That kind of helps with 3.1 modems that might be a little iffy. Like you put the OFDMA too high in the spectrum and they can't range properly. Maybe you want them to range on a single carrier QAM at 24 megahertz, and that might be more stable. In regards to downstream, once traffic starts flowing, it prefers the OFDM before it'll cross bond and bleed over to the single carrier QAM.
Okay.
Which is good because you want the 3.1 modems to be as efficient and effective as possible. So you want them to run higher modulation schemes if they can. That way you're not starving out your 2.0 and 3.0 modems that are still using the single carrier QAM.
So understanding that, right, we want the DOCSIS 3.1 modems to use the OFDM and the OFDMA channels, but in reality, what we see happen a lot of time in production and real live environments is DOCSIS 3.1 modems may have challenges locking to OFDM or OFDMA channels, and now they're just using the SC-QAM. And to your point, now we have 3.1 modems that are competing for the SC-QAM channels. They're utilizing traffic on the SC-QAM channels the same way that DOCSIS 3.0 and 2.0 modems are. But what are some of the reasons that will occur? Like, what causes a DOCSIS 3.0 modem, DOCSIS 3.1 modem to not lock to OFDM or OFDMA channels? What have you seen?
Are you saying it doesn't lock, or
it goes into partial mode?
All right, so it already registered in full mode, right? So it locked, if you're going to use that term locked, right? It locked on the OFDM, it locked on the single carrier QAM, so it registered properly. But later down the road, you have RF problems.
Right.
Then what's the beauty of 3.1 is, instead of going to partial mode, you do PMA. Where you drop, we call it graceful profile management,
yes. Where
from the CMTS perspective, we can look at every modem subcarrier MER and say, hey, he's not performing very well at 4K QAM, 4096 QAM. So let's drop him down to 1024 QAM, and now he's working fine. So instead of dropping the modem to actually partial mode, I do the PMA stuff first on the OFDM. And then if I'm really having problems, uncorrectable FEC, I drop down to the lowest modulation I can on the OFDM, and it's still crappy. Now I need to go to partial mode. So only secondary downstream channels will report CM status messages like FEC, unlock, QAM problems. There's a multitude of issues. There's even DOCSIS 3.1 CM status messages that will be reported to the CMTS, and CMTS says, hey, he's having issues with that RF channel. Let's put him in partial mode. He's still locked onto his primary. There's another reason why I kind of like the single carrier QAM primary. And then he might say, all right, it's the OFDM channel that's having issues. Channel 158, we might call it. So let's drop him down to 32 single carrier QAMs. So now instead of 33 downstream channels, he dropped down to 32, and they're all single carrier QAM.
Right.
Bad thing is, now this customer that probably signed up for 1 gig service is really
they're not going to get 1 gig service anymore.
Yeah. He might get 1 gig, but it's going to be hard pressed because he's going to be starving everybody else too.
And so you talk about like RF impairments being the reason why the OFDM channel will continue to go down to lower and lower order modulations, and could drop. We could have the OFDM channel configured for maybe even 64 QAM as its lower order modulation. And we might scratch our head and say, wow, why can't a DOCSIS 3.1 modem run at 64 QAM if that's the lowest order modulation, when it's able to run at 256 QAM for our SC-QAM, really narrow channels? And what I've seen in the field is our OFDM channel can be really wide, up to 192 megahertz wide. And if we're putting it at higher frequencies, or not even at higher frequencies, but various places in the band, you can get some really crazy things happen with that OFDM channel. You can get like standing waves in the OFDM channel, or at higher frequencies, you can get really significant roll-off. And so that can cause a lot of so we talk about all the different subcarriers, but that can cause many of the small subcarriers, the small channels within the OFDM channel, to fall below the minimum threshold that we need for even 64 QAM. And I know, John, we've talked about in previous episodes, but kind of like your guidance was that if about 10% or more of those subcarriers fall below the threshold, even if it's for 64 QAM, then that's going to cause that modem to no longer be able to use that OFDM channel, even at 64 QAM, and then we go into partial mode.
So by default, we say ignore or exclude 2% of the subcarriers before you make a decision. By default, me and Jason Miller were very much on the same wavelength of saying let's do 10% because we saw how robust it is with fast Fourier transform, with LDPC, the low density parity check, with the time and frequency interleaving. It's so robust that if you had 5% of 8,000 subcarriers, that's only what, 40 subcarriers, 5 times 8. So it's like
not that many.
Yeah. So if they had a low MER, do I really want to change my modulation for just a small subset of subcarriers that aren't really contributing a lot of problems anyway? We found that 10% is a good number to ignore.
Right.
That way, if you do have roll off, and 10% of 8,000 would be 80 subcarriers, and if each subcarrier is 25 kilohertz, 80 times 25, that's like 2 megahertz. That's it. Right? Or maybe it's 20 megahertz.
Small band.
Maybe 20 megahertz. Either way, it's like ignore 10%, and then you'll have less jumping of modulation.
Right.
Because you leave it at
more stability,
2%,
at least on a channel.
Yeah, more stability. The other one was the MER reading we used to make the decision is very conservative according to the Cable Lab spec. It's 6 dB more conservative than the actual breakpoint of those modulation schemes. So we tell people it's like, our default is that 6 dB extra robustness, but we tell people, change it by 12 quarters, which is 3 dB.
Right.
Split the difference. So if I know with DOCSIS 3.1, the breakpoint for 1K QAM is like 35 dB, but the spec or the default says 41, I'm like, if it goes at 40, I'm not going to have any uncorrectable effect, but I don't want to change modulation. So it's kind of like, let's split the difference, say 38 dB. Once I get below that, I still don't have uncorrectable effect, but once I go below that, then we'll start doing the graceful profile management and drop down. Now, my philosophical question to you will be, is it better to drop 3.1 all the way down to 64 QAM or go to partial mode? Like, what is better solution? What is...
So I mean, what my initial thought on that would be, I want to keep that DOCSIS 3.1 modem transmitting on the OFDM channel as much as possible, even if it's transmitting at 64 QAM, because I want to keep that traffic off of the SC-QAM channels if it's a DOCSIS 3.1 modem, because I want to use those SC-QAM channels for DOCSIS 3.0 modems, at least in today's world, knowing that majority of cable operators have more DOCSIS 3.0 and some 2.0 modems that are just starving for traffic utilization, particularly at peak utilization times on the SC-QAM. So if I can offload that traffic for, individual DOCSIS 3.1 modems, keep them on OFDM channels, that's going to help more users than that individual subscriber who, yes, his speeds may drop down on the OFDM channel, but he's still going to be able to use capacity on the SC-QAM. So we can spread that traffic across SC-QAM and OFDM.
I'm going to poke holes in that.
You do it.
One, if single carrier QAM can do 256 QAM, why would you want something to do lower than 256 QAM? So in that regard, I might say, I'll allow my OFDM to drop down to 256, but no lower.
Right.
To go lower than that, it's like, man, I could do better with my single carrier QAM at 256. Why would I do 64 QAM with my OFDM? Here's the other problem I have is, I agree with you if you are proactive enough to monitor the modems and modems are running lower modulation and you get on it.
Mm-hmm.
If you don't get on it at all and you leave them running, think about the OFDM. You're sharing it with hundreds of other 3.1 modems. That's time on the wire.
Right.
If you got one modem with lower modulation, he's eating up more of that channel than he needs to. He's not very efficient. So he's eating up more time on the wire, and everyone else wants to use it too.
My question back to you, or my retort back to you, because and I think I like this discussion. It's very interesting. So you can have many modulation profiles. I mean, as vendors are increasing that ability. Originally, we could only do like 4. Now we can do more than that. I don't know what Cisco can do right now. But if you have one or a few modems running on a low modulation profile, even if it's 64 QAM, it's 64 QAM over a very wide bandwidth. So can you still not do reasonable speeds at 64 QAM over a wide bandwidth? Doesn't that still give that subscriber the ability to get good traffic speeds?
It gives that one guy maybe the speed he's asking for, but you're still waiting to share it with other people. So instead of me being able to run 4K QAM and get my traffic done like this, it's going to take me more time in the wire to get my traffic done like this.
But not all subscribers are dropped down to 64 QAM. Only that particular user. Other subscribers could be at 4096, right?
Having 3.1 modems run lower modulation, you're going to notice the utilization of the 3.1 channel seems a lot higher than it should be, right? Because running lower modulation is going to take up more time in the wire to get his traffic done that he wants to do. He might still want to try to get 1 gig.
Yeah.
And to do that, he's going to have to stay on there longer. Whereas another guy that's running 4K QAM, he wants to do 1 gig, he's done in 10 seconds or whatever, you know what I mean?
Right.
So there's got to be an inflection point where you're like, it doesn't make sense to leave him in a lower modulation scheme, especially if I'm not tracking it. And hey, no one's complaining. Yeah, but why does my utilization look so high now? Because you have so many modems running lower modulation. It's taking them longer on the wire to get their stuff done.
So this may be something that, and you'll help me clarify this. This may be something that's unclear for me. And maybe this is kind of like Wi-Fi, where you have, a user's device that's really far away from the access point actually brings down the quality of service from people that are close to the access point. And what you're suggesting is someone that is on the lowest order modulation profile can degrade the performance of other modems that are on the highest order modulation profile. Is that kind of what you're suggesting? Yeah. And if so, can you help me understand that a little bit better?
I mean, when we say 192 megahertz OFDM at 4K QAM is worth almost 2 gigabits per second. When you optimize it, 2 gig. But if you're running 64 QAM, you can't get 2 gig out of it. So if I have a couple customers running 64 QAM, they might be trying to get 1 gig and maybe they can get it, but I still have to share that with you and you and you and you. So it's taking him much longer to get his stuff done. And by filling it up, it's going to look like the utilization is a lot higher than it is. And then the next guy wants to get on, he's not going to get the 1 gig he wants because I'm sharing it with the guy that's going slower.
Is that just for the users that are sharing the 64 QAM profile, or do they impact the users that are at the 4096 profile?
Everybody's still sharing that same channel.
Right.
That's like the hidden secret in the cable industry. We don't want to let everyone to know, like, yes, it's a shared medium. We're all sharing the same channels. It's not like if it was another channel that someone could load balance on 3.1, that'd be great. But you might not have the spectrum for 2 or 3 or 4 OFDM blocks.
Yeah. So for everyone who's watching this, don't tell anyone that cable is a shared channel. It's a secret out there, so keep that secret. Everyone in the chat room, thanks for joining in the chat. We'll keep that a secret too.
I used to make the joke that cable is like insurance industry. We want everyone to jump on it, but not use it.
That's a good analogy. I like that, John.
The more people we put on there, the more issues we could have. But it's definitely a shared medium, right?
Yeah.
So so I would go back and say, if I get below 256 QAM, my feeling is putting the modem in partial mode might be more efficient for everybody else. And the modem will be marked P online. Yeah. And it shows up as partial. So maybe it lights a fire under your butt to actually go fix something.
Yeah, we know we have a problem in the network. We have to fix it. And we'll talk about that shortly, about how we can fix that with different tools.
And why that customer might be getting lower quality of service. I look at it, it's always P online. And then you got to dive in deeper and say, all right, is he 32 channel partial mode? Or is he actually dropping all his traffic to the primary only? That's a different story. That's a case where you thought you have partial service set up, but the modem is marked partial, but he only had 1 bad RF channel, but the system wasn't optimized, and he actually pushed all his traffic down to primary downstream.
Yeah.
So now he's only got, 38 megabits per second max?
Yeah.
That's 1 single channel, right?
So that I like this. This is a good tip. It was something I haven't considered before, that keeping the lowest profile on the OFDM at 256 QAM is probably a really good recommendation, because that's one, it's going to optimize the OFDM channel for all subscribers, and two, if that modem can't support 256 QAM on the OFDM channel, it's going to move it to partial mode, and it's going to make it stick out. Go fix it then. And we have
If you can't use 256 QAM with OFDM, something's really wrong, and I'd probably rather have it go to partial mode and gave me a warning and an alarm so I can go out and fix it.
Now, what about for OFDMA? What are your thoughts for the lowest order modulation that we should use on the OFDMA channel? Is that a similar
interval usage codes? And IUC number 13 is the one the modem uses when it registers for OFDMA, and that should be the lowest one. Probably 16 QAM. Yeah, probably 16 QAM. I mean, even though you might be doing ATDMA at 64 QAM, in the upstream, it's just so many unknowns with the upstream, right? So 16 QAM is probably a good one for IUC 13. One, the modem uses that IUC to register, even though the initial ranging and fine ranging are usually like BPSK and QPSK. They're really, really robust modulation schemes. But 16 QAM is, if you can't work 16 QAM, something's really wrong, right?
Well, that's going to be my question to you, because recently I was working with a customer. Their upstream was so noisy, just across the whole spectrum, they could not get any of the modems to lock to the OFDMA channel unless they dropped profile IUC 13 to QPSK. Wow. So what would be your guidance there?
Where was the spectrum?
In the case where the return noise is just so bad that
Where did they put it? In what spectrum? What was the spectrum allocation? They put it on the low end? They put it up on the high end?
They put it in various places. There was so much noise in the return. So part of the issue is the customer has to work on fighting and mitigating return path noise. Yeah. But in the process of that, they have so much congestion on our SC-QAMs, they really needed the modems to use the OFDMA channel. So as part of that, they had to drop IUC 13 to QPSK just to get the modems to start utilizing OFDMA. And that helped reduce some of the overutilization on the SC-QAMs.
So what was the modulation on the single carrier QAMs?
It was pretty low. Right? Yes, I mean it's going to be low as well.
It reminds me of
they're using dynamic modulation on it, so I would suspect if we looked at the SC-QAMs, they're probably also dropping the QPSK.
Yeah, it's like, it reminds me of Terry on SCDMA, where people are like, I don't want to clean up my plant. Let's just run a technology that can just eat right through that noise.
Shoot through the noise.
Yeah. It's like, let's avoid it for another day.
Yeah.
But it's like, I don't know. I'm an RF guy, so are you. And it's like, ounce of prevention is worth a pound of cure. So if you could clean up the noise, because I assume it's HFC network, that noise is just going to exacerbate laser clipping. So, I mean, now you're going to have even more problems. I don't know about
it's a tough one.
Yeah, it's a tough. You got to get it working. I understand that. I'm curious where that OFDMA was in the spectrum. It does initial ranging by default 1/3 up from the lowest edge of the OFDMA. So you can change the initial ranging in that OFDMA block if that makes more sense. Like if you have high end roll off, you don't want the initial ranging at the very high end if it's roll off in certain houses. You might not want it at the low end if your OFDMA is in the low part of the spectrum. It's even noisier. So you can manipulate where it is. You don't want to put the initial ranging where it falls at 27, because that might be where CB radio is. So there's certain ingress points in the upstream. So you try to stay away from those points. Yeah, that one's a conundrum, man. They have to go down to PPSK.
Clean the noise out.
Yeah, exactly.
It's the best thing. Okay, so we got some questions in the chat here we want to take. We have Harb, a lot of people here. Harb, thanks for joining. I missed your top there. He says his son plays Valorant with DOCSIS 3.0. His ping is 15 to 20, but with a DOCSIS 3.1, it's 23 to 30. So it makes sense to me. So John, you were talking about the latency with spreading it over the OFDM channel. And I have heard some latency issues with other OFDM channels. With different things. So you can see, I guess, a little increased latency on that with gaming. So we are seeing that.
So the real question for him there would be, is he also running DOCSIS 3.1 upstream? There's definitely going to be more map advance and delay with OFDMA. It's funny. It's like we're going to add more speed, but it turns out there's more latency.
Yep.
So speed and latency don't go hand in hand sometimes, right? Latency would be like the snappiness of me hitting the button to shoot doing Fortnite or something, Call of Duty, and it actually reacting quickly. But even though we go to DOCSIS 3.1 and give people more speed, there could be more latency.
Yeah, and for gaming, I think that's where you're really going to see it on the upstream. So back to the chat room, Tim Bowser. Tim, good to see you. Thanks for joining. He said he had no choice. I was giving what the video guys would spare. I think he's meaning an RF bandwidth and allocation. So his SC-QAM block, very low frequency, 159 to 297 megahertz, and then his OFDM block is above 860 to a gig. So again, that's kind of what we're saying. Your SC-QAM's at the lower frequency and your OFDM is at the really high frequency, but he's doing okay with power adjustment modifications. So awesome. Good to hear that, Tim. Jeremiah, thanks for joining. He says code word efficiency between differing profiles is what really counts in the end. So
I was basically just saying, like we said, 4K QAM is going to be more efficient because it's a faster modulation scheme.
Yep.
So anyone using higher modulation will get what they need to do done quicker.
Absolutely.
They're on and they're off. And now it's open for the next person to use it, right? But you get some guy that's running lower modulation scheme, he's still going to do what he needs to do, but it's going to take him a lot longer to do it. So he's going to be utilizing that OFDM a lot longer. And here I am waiting to use that OFDM, but he's not done. And
yes.
It doesn't really work that way, but you know what I'm saying is you could go from an OFDM tracking the utilization, it's like 20% looks fine, and then all of a sudden it's 85%. You're like, what the heck's going on? Is there more traffic? No,
right.
There's more people running lower modulation.
Creating more code words on the channel. Yeah. All right, what else we got on the chat there? Harb laughing out loud. It's bad my son knows when I switched from DOCSIS 3.0 to DOCSIS 3.1. So yeah, I think that's definitely going on there. James, good to see you. Harb, good to see you again. Tech Junkie 28. My latency goes up every time they increase speeds. Years ago it was 8 milliseconds, then it went to 10, then 14. So I think we are, and that's actually good to see. It is what we expected. We are seeing increased latency with OFDM and probably OFDMA. We're seeing some more on the upstream as well. And then he's Harb saying, I hope DOCSIS 4.0 is better. So that, we are working more with low latency, and that's something that we're hoping comes into DOCSIS 4.0, and I think all operators are looking at that as well. Peter Vittman, great to see you. Thanks for joining again. Maybe the DOCSIS core has moved from ICMTS to VCMTS and DCA infrastructure, which can add latency as well. And that's a good point, Peter, as well. Depending whether we're using a distributed access architecture, whether remote PHY is pushed at the end, that also can have some impact as well. John, your thoughts on remote PHY versus our integrated CMTS, where we're using analog nodes and stuff. Do you think remote PHY will improve or cause negative impacts on latency?
I think DAA, distributed access architecture, moving from an analog fiber to a digital fiber has a multitude of pluses to it, right? Power, distance, MER performance, all that is just great. Removes a lot of equipment in the head end, puts the RF out into the field. The problem with remote PHY would be if I just upgrade an existing HFC plant to remote PHY, you haven't really changed the distance, which is great. Mm-hmm. But if you were to get rid of a hub site and put remote PHY in the hub site, and now your distance is 1,000 kilometers away, that latency adds in. Because the maps and the bandwidth request has to go from the cable modem at the house to the node through the digital network, maybe 1,000 kilometers away. So that time is still there because the CMTS is still the map processing engine.
Right.
Now that's why they came out with remote MAC PHY to put the MAC inside the node as well, so you could turn around the map messages quicker. Cisco came out with a pre-low latency DOCSIS feature called DPS. DOCSIS Predictive Scheduler. So we have a feature in the Cisco CMTS where we can give out maybe slightly more grants than what the modem asks for by looking at certain criteria. So if I do a ping on a long distance remote PHY solution or architecture, it might have said 30 milliseconds. I turn on DPS and it gets down to 8. So, I
Nice.
mean, I can get a lot better latency readings with DPS on. And this is why low latency DOCSIS came out with Cable Labs for something called PGS, Proactive Grant Service, the L4S, low latency, whatever. I think it's like four L's and an S, right?
The la la la, I think, was the technical term for it. So I think you covered it there.
But yeah, I think it's funny too. Is what is latency, and is latency as bad as jitter? Jitter is probably worse than latency.
Yeah. Con-
Jitter is
con-
the change in
continuous
latency.
latency or a continuous
Yeah,
ping time is manageable. It's when it varies, which is the
yeah,
jitter aspect of it. Varying
yes,
latency is the problem.
yeah. If everyone had the same latency, there would be no difference, or it's like a relative, right?
Unless
Um,
it's really, really big
yeah,
latency. I think they say like once you hit about 150 milliseconds of latency, then it's going to be unusable.
yeah. It's kind of like when I had my satellite dish here at home.
It was horrible, man.
I see my lips move like 3 seconds after I said something.
Yeah, we try not to remember those days, John.
I have fiber to the home now, so it's kind of nice.
Yeah. So yeah, then Tech Junkie says that he was kind of touching on that. So Cox has a service which you can pay to reduce latency, and it's their low latency. So he said 8 milliseconds ping, but now he has now now have 100% uptime. Before Cox would go down weekly due to power. So that's awesome to hear, Tech Junkie, that with Cox's service, you're getting something for that. He had to move on because the wife works from home when she's not on call. So good to know. So I actually haven't been able to take advantage of Cox's low latency service. Be interested if other people have used Cox's low latency service and to know what their experience are. Would love to hear in the comments or in the chat from other users if they're what their experience is with Cox's low latency. I know other cable operators. I know Comcast. I know Shaw. Now Rogers is also working on low latency solutions. And if anyone has experiences with that or using it, we would love to know what your experiences are. So John, we talked about DOCSIS 3.1, bonding with OFDM channels and recommendations there. So tools we can use to help benefit that. You've mentioned PMA. You have PMA in the CMTS and how that kind of changes from one profile to another. And we also have PMA external to the CMTS that will enter commands into the CMTS to do kind of a more granular change of the profile. And what we do there is we look at RxMER per subcarrier. So we look at basically every cable modem and its performance on an RxMER per subcarrier. So we're basically looking at that OFDM channel in the downstream or the OFDMA channel in the upstream. And then we develop a profile, and it's not a flat profile anymore. So it's not like a constant 4096 QAM across.
Our simplified peripheral management would be 4K QAM, 2K QAM, 1K QAM, 512, 256, QPSK, 16 QAM. We can support all of it. But normally you're making very simplified, keep it simple, stupid. The
Right.
KISS principle. Make it just flat across the board. When in reality, if you want to get more complex, maybe it is better to offload some of that processing to an external device and say, all right, this guy has a graph that looks like this is for MER. So I'm going to make a specialized profile just for him where in here it's 4K QAM, in this spectrum it's 2K QAM, in this spectrum it's 16 QAM. But now I got a little more processing. I need to look at all this stuff and then tell them, hey, I made a profile just for you.
Just for that individual subscriber's modem. And that way, that modem, at the low frequency, it could operate at 4096 QAM. At the mid frequency, it may have to drop to, maybe 64 QAM. And then at the high frequency, it can run at 1024 QAM. And you could have, I just explained like 3 different steps in that profile for that individual subscriber's modem. But you could have lots of impairments in there, and you could have 20 different modulation steps where it could get really, really complex. But what that allows that subscriber's modem to do is overcome all the different impairments. And in the downstream, it might not be that hard. You don't run into that many impairments in the downstream, but in the upstream, you have all kinds of noise impairments and different types of challenges to overcome. And what's more is those impairments could change every hour, every couple of hours. So you kind of want to be monitoring those impairments, that RxMER data that's coming from the modem very frequently, and then applying those profiles into the CMTS as frequently as you can so that you're improving that quality of experience and that speed throughput to each individual subscriber as frequently as you can, and then also making sure that that subscriber remains locked to the OFDM or OFDMA channel as long as you can. So again, they're getting as much speed as they can, and then you're also ensuring that because the modem is locked to the OFDM and OFDMA channel, we're offloading traffic from the SC-QAM so that your 3.0 modems and any 2.0 modems that are still out there are now able to get more traffic on the SC-QAMs because we're freeing up traffic on the SC-QAM channels.
3 points. One.
And do you have any sub points to these?
Now I'm going to forget all my points. Maybe someone can run with this. I think this is a good patent idea. Wouldn't it be cool if a modem was running different modulation in the spectrum for downstream, and the CMTS and modem used the highest modulation in the spectrum first instead of just striping across the entire thing?
Oh, that's brilliant.
And they might be able to get it done because I only need to do a little bit of traffic. So why not use the upper part of the spectrum at 4K QAM than to waste time where my house has low MER and low performance?
I think this is a patentable. Okay, everyone, again, don't tell anyone about this because we're going to go patent this. So
yeah, I think it's a cool idea. So that's one idea I think would be kind of cool. It's not there yet, but maybe with machine learning and artificial intelligence and external processing, maybe that's something that comes down the road. And then we start activating the 8K QAM and the 16K QAM that's in the spec as a May. No one ever implemented it yet in the modems, but maybe that's something we could do.
But particularly with the external processing, because we're continuously doing that, we don't have to force the CMTS to do this additional processing. But
if you did remote PHY with no amplifiers or maybe one amplifier, I bet you the MER would be good enough to actually do a higher modulation scheme too. So that was my one point. The second point was in regards to upstream. Remember we talked about this before. We scheduled traffic on mini slot 0.
Yes.
Farthest left in the spectrum.
So it should even be easier to do in the upstream then, because we know what IUC is at what modulation. So the first IUC could be a real high modulation or maybe a real low because it's lower in frequency, and the last IUC could be suffering impairments.
I said this would be cool for Cisco, but we don't do it. Would be allow the end user to select where to start their usage. Instead of mini slot 0, like the spec says, like if I know I'm going to, like, remember one of our MSOs, they wanted to put the OFDMA from 8 megahertz to
I know who you're talking about.
We know it's crappy. And we also know the CMTS schedules at the very low end where it's worse.
Yes.
So in that regard, I would be like, let me start scheduling traffic at 10 megahertz or 15 megahertz above, and then wrap around if I need to.
So you can avoid the noisy parts of your OFDMA channel because you know where they're at. So giving the cable operator that ability, and end user, you're meaning the cable operator, not the subscriber. But
let's take it a step further, right? Instead of I would say, all right, I'm going to give you the opportunity to select where you start your traffic. And later on, I'm going to have processing that will say, where's the highest IUC? And I'll start traffic in that spectrum.
Yeah.
You know what I mean? Like we just talked about for downstream.
Again, ingenious. I told you. Ingenious, John. I love it.
My third point was, a lot of people don't know this, but just because a modem says he's doing 33 by 4, meaning 33 downstreams.
And 4 upstreams.
And 4 upstreams. We bond at the service flow level. So just because a modem says he's doing 33 doesn't mean the service flow that's actually running is using all 33 channels.
Right.
So sometimes you have to go deeper in the modem, do like a quas verbose, or look at that individual MAC address and say, let's look at the verbose, all the information. Look at the service flow and say, oh, here's a voice service flow. He's using the primary only. Okay, makes sense. I wanted him to do that.
Yes.
Here's another service flow. For some reason, he jumped on an 8-channel bonding group. Why the heck's he doing that? Why isn't he doing 33-channel bonding? You know what I mean?
Yep.
So sometimes you have to go a little bit deeper to understand why the speed is not what it's supposed to be, because he might not be bonding like you think he is. Just because he registered that way doesn't mean he's doing it.
The truth is not always on the surface. You have to deal deeper. That's a really good point. And I think particularly like when you look at just monitoring systems, they give you that false impression that, hey, this modem's really healthy. Yeah. But the service flows tell you the details.
Like he's not in partial mode. He's full bonding mode, but you don't know if the service flow is actually doing full bonding.
Right.
So sometimes you have to go a little bit deeper to find out. I even had another one where, and it was a modem issue where if I had a voice call going the same time I did a speed test, the speed test would suffer.
Yes.
If I shut down the voice call, the speed test was fine. If I pushed the voice call to a primary only downstream and then did a speed test at the same time, it was fine also.
Yeah.
But when I bonded the voice and then tried to do a speed test, it would suffer like really bad.
Now, and that's interesting you brought that up, because recently was working with a customer, and they've added OFDMA, they've done some optimization, but their speed test got worse, and they're trying to understand why the speed test got worse after seemingly adding more capacity. So to your point, I think that need to focus on looking at the service groups and just seeing, well, are we actually truly bonded, or is the quality of service in the service groups bonded the way that we think they are? So doing that deeper dive is really, really important.
Is it a 3.1 modem and it's going to prefer the 3.1 spectrum, and is it running the highest modulation or not?
Yes. So some okay, thank you, Mia. Thank you for back to some questions. So James Peta, I hope you're saying your name right. Thanks for joining us. He says the industry adoption of LLD, which is low latency DOCSIS, we love our initialisms in the industry, has been a bit slow, and I totally agree with you, James. We need to kick it in the butt. I know there are new updates with LLD virtual queue underway with L4S. John mentioned that earlier. What are your predictions on its adoption and value to the network? John, do you have predictions and adoptions on that?
For what, the LLD or DOCSIS 4.0? All the
I would say LLD and L4S.
Yeah, L4S I think was kind of scrapped because I think it takes a little bit more on the OSI model. That's not even part of the DOCSIS plan.
Yeah,
it's
tagging traffic and stuff like that is tough.
Yeah, and that's the other crazy thing is, how do you determine which traffic to tag, I guess?
Yes.
So
who's more important?
Yeah. And then what will happen is someone will figure out how to hack it.
Yes, and they'll tag their traffic.
I'm going to tag all my traffic at low latency, so it doesn't. Everyone's back to the same thing. Or
I think low latency DOCSIS, though, everyone kind of unanimously agrees that is important. So I think that's going to get adopted. I mean, we see Cox success stories already just in the chat itself. So that's going to happen, but how it happens and when it happens, I think is really unclear.
How it's really implemented. PGS, I've done a lot with different service flows on the upstream. There's NRTPS, non-real-time polling service. There's something called real-time polling service. And the non-real-time polling service was something we would utilize for a modem for voice calls. And what it did is I would assign an NRTPS flow to call signaling. So if I picked up the phone and went off hook to get dial tone, the cable modem has to make a bandwidth request.
Right.
But that's contention. It could have a collision, have to back off. And if it's congested upstream, you're going to have a lot more collisions and not a lot of traffic. So to give yourself insurance that me getting dial tone and dialing digits before the call even sets up, I'm going to do NRTPS to guarantee that EMTA, embedded multimedia terminal adapter, the voice modem, to have guaranteed unicast bandwidth requests so he can set up the call. Right. Once the call is set up, then it goes to a UGS flow, unsolicited grant service, where I set up the call. Instead of asking for grants all the time, request, grant, the CMTS is like, oh, I'm going to give you a grant every 20 milliseconds.
Yep.
That's UGS. So we took that a step further and called PGS, proactive grant service, which is sort of going to do some of this stuff, but give out grants without having to do request, grant, and try to do it not just for voice, but some type of tag services like gaming, so that I can do this PGS flow and say, all right, give him a unicast bandwidth request, maybe 2 mini slots or something really small, every so often, so he's guaranteed to get through, not have a collision, not have to back off, and then once he sets up, his flow is more evenly spaced.
Yeah. I mean, it's really just UGS, but it's UGS for other services.
Yes. Yeah. And then you're guaranteeing space every so often, so you're not worried about jitter and latency.
Right. Cool.
So yeah, it's coming. It's needed. Some of it's there. Someone mentioned AQM, active queue management.
Yeah.
That's in the upstream by default. I don't know. We were looking at implementing it on the downstream, I believe. I can't remember. Um, but yeah, it's definitely coming. Like I said, Cisco has their own proprietary feature called DPS, which has been working pretty darn well. Um, it's our first foray into it, right? Before PGS got finalized, and now
Yeah.
we're working on PGS as well.
And Tech Junkie says that no one's going to pay for low latency because it's not necessary. It would only work for the game server. We're on the same network. Once you jump off the network, then it's out of their hands. Now, yeah, so I think there will be people who are skeptic on low latency, but there was a study, and we had talked about the statistics on that because cable operators do studies on like would you or would you not pay for low latency. I don't remember the exact numbers, but I think there was a pretty big percentage of people that said they would pay some amount of money. It wasn't a lot of money. It's like $5 or something per month that would be willing to pay for low latency. And it's a lot of people that are like gamers and things like that, which is a large number of people that are willing to do that. They're just not willing to pay a lot, but it has to be proven. And that's why I'm really interested in more people who are using services like Cox who are have that low latency capability. Peter's talking, so Peter's mentioning the AQM is not the low latency DOCSIS stuff. AQM can be helpful to avoid buffer bloat on congested connections. Low latency DOCSIS will decrease the latency. So Peter, thanks for clarifying that. Tim says, indeed, regarding the insurance job, I think we missed that one, so that must have been off there. However,
we talk about cable is like insurance, right?
That's right.
We don't want people to use it.
Yeah. And then Peter talks more about the AQM can help improve the overall latency experience, and I think that's just meaning because it helps with the buffer bloat. So it's not directly related to low latency, but it can help the experience.
I think as an industry, we're looking for revenue generating units. So people are cutting the cord, meaning get rid of regular video. They're going to high speed data. But how can we get more money out of people?
Right. Yes.
What can we offer for better quality of service that people will pay for?
Yeah.
And one of them would be low latency DOCSIS and optimizing it and rolling it out efficiently, I guess, to show value.
Yeah, it's down to ARPU, average revenue per user, is what cable operators are really focused on. So I think the last thing we wanted to just kind of tie into this is proactive network maintenance. So that there's a lot of industry experts who say, particularly as DOCSIS 3.1 gets more rolled out with OFDM and OFDMA, and especially as we look at DOCSIS 4.0, the importance of proactive network maintenance becomes increasingly important. So we talked about PMA. How it's kind of adjusting the profiles. If it's in the CMTS, it's at a coarse level. If it's external to the CMTS, it's at a granular level. But then, to your point, like we can see that a cable modem's in partial mode because it dropped that OFDM or OFDMA channel. Where PMA can really come in is it can show you that RxMER per subcarrier. It can show you individual modems that have really degraded RxMER per subcarrier. But then we can apply machine learning to PMA as well. We can show you clusters of modems that have commonality, that have like an outside plant impairment. And there's a cluster of modems now that may have RxMER per subcarrier that's completely degraded. We can localize that impairment. And that's where we can now really start to go out and say, okay, we know it's not a common issue. It's not an in-home issue, but it's a common issue that's degrading all modems. And we can show you exactly where that is an outside plant. Many times we can even know what the impairment is, like LTE ingress, for example, might be the problem, or it might be just roll-off that's a problem. And now we know it's an amplifier that doesn't have enough gain, or a passive device that's causing that roll-off. So now we can start to very quickly say, okay, we know there's a problem because modems are in partial mode. That's what the partial mode is telling us, or even PMA with the profiles that it's generating, we can see that very visibly. Now PNM comes in and gives us visibility to where the problem is and what the problem is, and then we need to go fix the problem. That was your point at the very beginning, John. We don't want to use 64 QAM because that's going to degrade the quality of experience for all subscribers. But we need a tool like P&M to give us visibility to quickly address that problem so we can get those modems back using OFDM or OFDMA in the upstream, fix the problems. And there's a huge synergistic relationship by combining P&M and PMA. PMA is kind of like that Band-Aid that can help the modem stay on the OFDM channel, optimize the OFDM or OFDMA channel, and then P&M comes in to give us visibility so we know where the problem is and how to go fix that problem.
We can't wait for the customer to complain.
Yes.
We're putting a lot of self-healing features in the CMTS to keep the modem online, keep running traffic. But if no flags are being raised, you're not going to fix anything, and then it's just going to get worse and worse and worse. And it's affecting everybody, and you don't realize it. So, we need proper visibility, right? So here's another patented idea I think would be kind of cool is if we do have machine learning, AI, artificial intelligence, and we have external devices to keep track of every modem, wouldn't it be cool if you allocate more spectrum, you've opened up the spectrum, you have multiple OFDM blocks and all that, and you could say, hey, this modem has had issues in the past at this frequency, so don't lock on that OFDM block, but you can use the other block. Right. That way he never goes into partial mode. Like, remember back in the day when we had DOCSIS 3.1 modems that were 8-channel bonded? Well, we might have had 32 channels. So you have 4 groups of 8 that modem could go to. So instead of making that modem go into partial mode, why not just say, hey, he's had issues here.
Never try to put him back there again.
Yes, exactly. So that would be a good idea too. It's like, but it's more complex, more CPU. But I think we're getting to that point where memory and computation power is getting much cheaper and smaller and faster. And so I think that'll come down the line where we can do stuff like that and say, this modem has a history. He looks bad. He has high-end roll-off. Don't let him use the OFDM block from 1 to 1.2 gig.
And we're continuing to evolve. Yeah, we're continuing to evolve PMA. So right now PMA is focused on OFDM and OFDMA, but we're looking at using PMA to also manage modems on the SC-QAM channels. So I think exactly, whether we patent that idea or not, we won't tell anyone. But exactly to what you're saying, there's opportunity because there's newer CMTSs might be able to build this in. The vendors can add this, but it's going to be a long time. There's a lot of CMTSs out there that just won't be able to upgrade to this because they don't have the processing capability. But from a PMA standpoint, this is all software that runs in modern day, high CPU capable devices, and we can upgrade the software in PMA to say, okay, now we're going to start managing modems on the SC-QAMs, and we can do exactly what you're saying. We can look at how each individual subscriber's modems has been performing historically and then make intelligent decisions on how to manage those modems in the future and keep them off of channels that just don't work well so that we can continue to improve that customer's or that subscriber's quality of experience. Because to your point, historically, we've relied on the subscriber to call in and say, my service is not working, I'm having poor quality of service, please help me. And that is just not a way moving forward as an industry that we can continue to do things. We have to get smarter, we have to have better tools, and we can absolutely do that with software. We can make that subscriber better.
The old joke was Ma Bell status monitoring.
Calling on the phone, hey, my mode's not working.
I got my status monitoring. It's called my end customers.
Yeah. So Peter says it's sad how less the CM web GUIs are reporting, especially for OFDM and OFDMA upstreams and downstreams. Totally true. It's like we don't get good details off of modems, and a lot of operators are even locking access for modems. So there's just not good data you can get off of that. That's why we have to use tools like PMA and P&M to get good detail on what's actually happening in the plant. And then Tech Junkie says, that's interesting. I would have thought few people would pay for it. But yet, there are studies out there on that. So he says, I know a lot of gamers, and none of them even know about the Cox service. That's interesting. I'm surprised they don't do better advertising on that. Maybe they're not promoting it. It is so the Cox service is $5 a month. So that's right in line with the basically the study that we saw. Yeah. So very, very interesting. So with that, John, we are wrapping up the top of the hour. Is there anything that we missed on the topics that we wanted to cover?
I would think also a revenue generating idea. I don't know if many offer it, but what about VPNs? What about security?
Yeah,
You
so
know,
I mean, I know that is something that some operators are providing. From the security standpoint, I know they offer a number of the large MSOs offer security solutions, but VPN, I think you get into some areas of you know concern there. So there and there's a lot of third parties that offer VPNs, but I don't know that that's something that cable operators are offering.
yeah. I know when I work from home, I'm usually running VPN through Cisco,
Yep.
and then when I turn off my VPN, I notice I get a lot more junk email. So it works to block some of the chatter, the crap
Yes.
in the background. It's nice to have everything encrypted, I think.
I myself am a huge advocate of VPNs. I mean, I would recommend them to people. I can definitely see the security reasons why cable operators may not provide VPNs for various reasons. Keep them on their network. It might be good, but I don't know about that.
Also, when doing speed test, there's a few things you should get rid of. Get rid of Wi-Fi, get rid of
Yes.
VPN, and make sure you're wired up. Do the biggest Ethernet packet you can if it's not randomized. There's a lot of little tidbits about doing speed tests to get the best, results.
Yeah.
That way you can baseline it first and then start throwing. Like VPN, I think adds 50 bytes to every Ethernet packet or
It's going to add overhead.
Yeah, it's a lot of overhead.
And definitely a speed test on Wi-Fi. You're really just testing your Wi-Fi network. You're not testing what your true connection is over the DOCSIS network. So I think that's a good point on that. So great. Yes. So Tech Junkie also says people use VPN to avoid the ISP, particularly make sure they're not spying on you. So good point there. All right, John, a lot of good information. This brings us to the end of another enlightening episode of Get Your Tech On. I think we've covered a tremendous amount of ground and a lot of insights on managing DOCSIS channel bonding, ensuring the optimal performance of your HFC network. So thank you so much, John. You gave us a lot of great information. We value your immense expertise in guiding us through this journey tremendously. So as always, everyone, we're here to just continue to provide this information. Would love for you to drop your comments below if you weren't on the live chat. We appreciate everyone in the channel. Please do hit the like button, subscribe to our channel, and click the notification bell. Click the little buttons below there. We appreciate very much. Mark your calendars for an unmissable event on August 18th as we'll welcome the return of the brilliant Ron Rannick to the show. He's going to be covering legendary insights on ingress and promising a truly enlightening experience there. So you won't want to miss that show. So from all of us here, you keep joining us. We'd love to see you on the next show. Until next time, goodbye and have a fantastic time. So long all.
Take care.